Alright, so in this video we're going over linear functions from SAT Algebra. This is going to be the first of our SAT Math series. So yeah, okay. A linear relationship is any relationship between two variables like x and y that makes a line when you graph it on the xy plane. So for example, if we have these two variables and x is always equals to y, like when x equals 1, y equals 1, x equals 2, y equals 2, x equals 3, y equals 3, then it's just a straight line passing through the origin with the equation y equals x. Okay, it's just showing you the relationship between these two things. It's really common to see in the wild as well. Okay, there are two ways you can express linear functions. One of them is in slope-intercept form. So y equals mx plus c. Y and x are variables and m and c are constants, which means they don't change. They're going to have a fixed value, and they're showing you how y and x change compared to each other. M is your gradient or slope, and c is your y-intercept, where x is equals to 0. So here our y-intercept is 0 and our slope is 1. Standard form is just rearranging this, so it's in the form ay plus bx equals c. This independent term is your y-intercept. You just need to rearrange it. Okay. Yeah, so m is your slope or gradient, and it's basically like the steepness of your line, like the rate of change of it. So the gradient is your change in y over your change in x, your rise over your run. So like you take any two random points, the rise over the run is your gradient, the change in y over change in x, and you write it as y2 minus y1 upon x2 minus x1. And the keywords that you need to look out for in word problems when you're looking at your slope or gradient is rate, per, and each. Okay. Your y-intercept is c. So this is going to be your y value when x equals 0. It's the point where the line crosses the y-axis. So over here, it would be here. This is your y-axis. This is your x-axis. And the keywords we're looking for this are initial, starting, and one time. Sorry about my handwriting. Okay. Just to recap, these are our important formulas. The formula for gradient, y2 minus y1 upon x2 minus x1. And this is your equation of a line. So if you have a set of coordinates 5 and 2, and your gradient is 6, then you can just find the equation of the line by doing y minus y1. This is your x1 and y1. Y minus 2 equals 6, x minus 5. Y equals 6x minus 30 plus 2. Y equals 6x minus 28. Okay, now let's do some practice questions. Take a second to solve this yourself as well. So we can see it's a line, a straight line. Y equals 4x plus 28. Our x-intercept is where y equals 0. So this is going to be, and our y-intercept is at b. Okay, what we know is that the y-intercept is 28 from this, and the gradient is 4. So we know that b equals 28. We also know that the gradient is equals to 4. So what we don't know is a. Now to solve for a, we can just substitute in y is equals to 0, and we get 0 equals 4a plus 28. Subtract 28 from both sides, and you get minus 28 equals 4a, and you get minus 7, yep, equals a. So 28 minus 7, a plus b equals 21. So our answer is a. Okay, next question. Okay, let's draw our line. I'd always suggest to draw things out. You can of course use Desmos for a lot of these questions, but like I'm always gonna suggest like do it on paper, understand the concepts, and then use Desmos for checking if you have time. I'll make a video going over Desmos as well. Okay, so the line K has a slope of 5 and a y-intercept of negative 35. So the line is something like this, not like that, like this, yeah. We know that this is minus 35, 0, minus 35, and we don't know what this is. This is our line K. So we know the slope is 5, right? We have two coordinates, x, 0 and 0 minus 35. What we can do here is use our gradient formula, m equals y2 minus y1 upon x2 minus x1. 5 is equals to 0 minus 35 upon x minus 0. Be careful of the order you're putting these in. 5 equals 35 upon x, which means x equals 35 upon 5, which is 7. Okay, next question. This is a linear equation, as we can see, because the highest power of x is 1, right? So a company's total cost, CX, in dollars to produce X shirts is given by the function above. So X is the number of shirts. Just label what your things are showing. Okay, the total cost to produce 100 shirts is 800. Basically, our x, y in this is like the number of shirts by the cost. So let's write our coordinates. So for 100 shirts, it takes $800. And we need to find how much 1,000 shirts cost. So let's take our equation. So we don't have the value of the gradient. So what we'll do is solve for that first. 800 equals 100m plus 500. Just cancel the zeros. Divide both sides by 100. We get 8 equals m plus 5. 3 equals m. Now we have our equation. The cost is equals to 3 times the number of shirts plus 500. So now we just substitute in this value of x, this value of the number of shirts, 3 times 1,000 plus 500, and the cost is equals to 3,500. Okay, yep. If you guys have any questions, any suggestions, anything, please drop them in the comments. If there's any other question you'd like to go over, please send it in on WhatsApp or Instagram. They're linked in my bio. And please like, please subscribe, and see you next time.